Hi kids, we'll be going with this small question, small values. So there is some kind of ring here which has given horizontal velocity 10 meters per second, and mass of the ring is 1 kg and radius of the ring is 1 meter. Radius of the ring is 1 meter, which I didn't mention here, but take it as 1 meter, right? Now mass of the ring is 1 kg, so weight will be 10 Newton. If weight is 10 Newton, normal reaction is going to be 10 Newton, because you can see center of mass is not moving vertically downwards. So net force along vertical direction must be 0. So normal reaction will be 10 Newton. Now you can see there is no rolling initially, so it will try to slide. So bottommost point will try to go this way, so friction will be acting in the backward direction. As there is slipping, friction is going to be maximum, which is mu into n. N is 10. Mu is 0.5 given in the question, 0.5 into 10, maximum friction is 5. So friction will try to produce, friction will be acting this way, which will try to reduce the relative motion. You can see how it reduces the relative motion. What will happen is it will try to reduce this velocity and it will try to create this angular velocity. So V minus R omega will become slightly less. But eventually what will happen, if you see at any moment there will be V in this direction and R omega in this direction. V was initially 10 and R omega was 0. Now friction is trying to reduce this and it will try to increase this, and eventually they will become equal. Now if they become equal, what will happen? There won't be any slipping here, so pure rolling will happen, then friction will disappear. After this moment there won't be any friction. There won't be any friction. You can see after this moment velocity is going to be constant. So let us find what is that velocity and what time it will happen, right? So for that what we will see, we can see velocity is reducing, so we will try to write V equals to u plus at. Similarly, angular velocity is increasing, so we will write omega final equals to omega initial plus alpha into t. Now if I want to find acceleration, then the net force, friction is the only horizontal force, 5 equals to m into a. So acceleration is 5 in this direction. Similarly, if I want to find alpha, I will be taking torque about center of mass, because torque due to pseudo force is going to be 0 about center of mass, right? So net torque is going to be this distance, which is 1 into 5. Torque equals to I into alpha. From there I will be getting alpha is 5. Now I will be writing V equals to u plus at. U is in this direction, acceleration is in this direction, so V equals to 10 minus 5t, and omega is initial omega plus alpha into t. Now I need to see when V will become equals to r omega. When I substituted V equals to r omega, I got t equals to 1. That is, after 1 second V will become equals to r omega. When I substituted the t equals to 1, I understood that velocity is going to be 5 and angular velocity is going to be 5. So that is, it is going to look like this. Final velocity and angular velocity is going to be 5. Initial kinetic energy is half into m into v square. Rotational kinetic energy is 0. Final kinetic energy is half into m into v square plus half into IC into omega square. Initial kinetic energy is 50. Final kinetic energy is 25. 25 joules is gone as heat, because friction is doing work, right? Yeah. So now I have solved the same question by taking mu is 0.25. Then I got F equals to ma, acceleration is 2.5, alpha is 2.5, then V equals to u minus at, omega equals to 0 plus alpha into t, and when will V become equals to r omega, I have seen. I understood it will happen after 2 seconds. That makes sense, because friction is less, it will take more time. But the good thing I understood is velocity and angular velocity are turning out to be the same thing as previous question. So if velocity and angular velocity are turning out to be the same thing as previous question, then the kinetic energy loss also is going to be the same thing as previous question. So somehow we are ending up with velocity same as previous question. So let us generalize and do it. Let us take the mass as m and radius is r, and moment of inertia is beta mr square, where beta is some constant value. So for a ring it is 1, for a disc half, for a solid sphere 2 by 5, hollow sphere 2 by 3 and stuff, right? So again we will be going by the same thing. F equals to ma, the only force is friction, so acceleration is this much. Torque equals to I alpha, so angular acceleration is this much. So velocity is initial velocity minus acceleration into time. Final angular velocity will be 0 plus alpha into t. We want to see when V will become equals to r omega. When I did that, I got time as this thing. Now when I substituted this time back, then V will be equals to r omega anyway, so that is turning out to be u by beta plus 1. So it's kind of not depending on mu value. Final velocity is not depending on mu value. In fact, it doesn't depend on the radius also. It depends only on that beta thing. It doesn't depend on the mass value. It doesn't depend on the mu value. It doesn't depend on the radius value, right? So something is happening. At least it doesn't depend on the friction. that you can see. If friction is more, it is coming to that position quickly, that situation quickly. If friction is less, it is taking more time. So friction is playing only role in the time, but it is not affecting the final situation. It is not affecting the final situation. Now anyway, initial kinetic energy is this much, final kinetic energy is this much, that I don't have to bother much. Or you can see like finally it is trying to, you will be feeling like it is rotating over the bottommost point and stuff. Anyway, so it doesn't depend on the friction. It doesn't depend on the friction. So there comes the catch. Now if it doesn't depend on the friction, you can see when I take torque about point P, torque due to this mg and normal is also mg. So torque due to mg and mg will get cancelled. They are kind of behaving like internal forces. So torque due to mg and normal will be 0 no matter about which point you are going to take. Now torque due to mg and normal is 0. Torque due to friction, if I can make it 0, then I can do conservation of angular momentum. So if I take torque about this point, then torque due to mg and normal will be 0, but torque due to friction won't be 0. So I can't do conservation of angular momentum about this point. So wisely we will be choosing about this point. So torque due to mg and normal is 0, torque due to friction is also 0. So I can say angular momentum of the system will be conserved. Now what is the initial angular momentum of the system? It's angular momentum of center of mass and about center of mass. Initially angular momentum of the center of mass is this much, angular momentum about center of mass is 0. Finally angular momentum of the center of mass is this much, angular momentum about center of mass is I omega. But we know eventually V equals to R omega. So when I substitute V equals to R omega, I will get this equation as this thing, final velocity as this thing. Now we will be getting this equation much quickly because we understood it doesn't depend on mu value. So we try to eliminate friction by using conservation of angular momentum. Once I know final velocity, I can use V equals to U minus AT and I can get the time quickly, right?